All right, let's dive right in. We're going under the hood to talk about a piece of engineering that's, well, nothing short of legendary, Honda's VTEC. We're going to figure out how this one technology managed to give a single engine two completely different personalities. For the longest time, this was the ultimate puzzle for engine designers. You could build an engine that was super smooth and sipped fuel on your daily commute, or you could build a screaming, high-revving monster for the racetrack. But both in one engine? Yeah, that was pretty much the dream. So to really get why VTEC was such a game changer, you have to understand the problem they were trying to solve. And it all boils down to one critical part, the camshaft, and a major trade-off that designers were forced to make. Okay, so think of it like this. On one side, you've got a camshaft with these gentle, rounded lobes. They open the engine's valves just a little bit for a short time. Perfect for low speeds, right? You get great fuel economy, a nice smooth idle, the whole 9 yards. But on the other side, you've got this wild, aggressive profile. These lobes throw the valves open way wider and for way longer, cramming as much air and fuel into the engine as possible for insane power. The catch? Before VTEC, you had to pick one. That's it. So Honda's engineers, they looked at this pick one problem and said, nah, we're not doing that. We're going to find a way to have both. And their solution, well, it kicked off a revolution in engine design that you can still feel today. And they called it VTEC. It stands for Variable Valve Timing and Lift Electronic Control. Now that lift part is absolutely crucial. See, a lot of systems can change when a valve opens. That's the timing part. But VTEC was different. It's a cam switching technology. It physically changes how far the valve opens. That's the lift, by jumping between two totally separate cam profiles. It's brilliant. So at the end of the day, VTEC wasn't just some gimmick to make engines louder or faster. It was about making them smarter. It let a regular engine act like a sensible, fuel-sipping commuter car, and then, whenever you wanted, it could flip a switch and turn into a high-strung performance machine. It was truly the best of both worlds. So, how does this mechanical magic trick actually happen? Let's take a look at the sequence of events that creates that famous moment when, VTEC kicks in. Okay, let's break it down. You're just cruising along, maybe going to the store. The engine's at low RPMs, just chilling in its efficiency mode. It's using two mild cam lobes that keep everything running smooth and quiet. But then you see an open stretch of road, and you put your foot down. The car's computer, the ECU, immediately sees this. It sees the high RPMs, the wide open throttle, and it sends an electrical signal to a little part called a solenoid. That signal tells the solenoid to open up, and when it does, it sends pressurized engine oil, literally the lifeblood of the motor, shooting down a special passage. And here's where it gets clever. That blast of oil pressure shoves a tiny little pin sideways. This pin slides through all the rocker arms and locks the two mild-mannered ones to a third high-performance rocker arm that was, up until now, basically just tagging along for the ride. And just like that, bam, they're all locked into a single unit. Now they have no choice but to follow that aggressive high-lift cam profile. The valves are flying open wider, staying open longer, and that's the feeling. That's the surge of power you get as the engine completely changes its character. But Honda, being Honda, they didn't just invent this incredible system and call it a day. Oh no, they kept refining it, evolving it into a whole family of technologies, each one tweaked for a different job. It all started back in '89 with the original legend, the DOHC VTEC, built for pure performance. Then in the '90s, they gave us VTEC E, which cleverly used the same ideas to focus on incredible fuel economy. By 2001, we got Intelligent VTEC, or i-VTEC, which added continuous cam phasing for a much smoother and wider power band. And now, we have VTEC Turbo, which pairs the concept with modern turbocharging. And you can see their different goals pretty clearly here. The original VTEC was all about that top-end rush of power. VTEC E, on the other hand, was all about sipping fuel at low speeds. Then i-VTEC came along to try and find that perfect sweet spot, balancing power and efficiency across the entire rev range. And what's really fascinating is that even the name i-VTEC doesn't just mean one thing. In a sporty car like the Civic Si, it's the full-on three-lobe system designed for maximum horsepower. But in a daily driver like an Accord, it might be a simpler version focused on efficiency. And get this, in something bigger like an Odyssey, it's even paired with a system that can shut down half the engine's cylinders while you're cruising on the highway to save a ton of fuel. So yeah, the mechanics are incredible, but VTEC's real impact, its legacy, goes so much further. It fundamentally changed how we all think about small engines.
I mean, it completely turned small engine performance on its head. It proved you didn't need a huge, thirsty V8 to have fun. It showed the world that power and efficiency could actually live together in the same engine. And of course, its success pushed almost every other car company to develop their own version, sparking a huge wave of innovation. It became a cultural icon. And, fun little fact, the core idea actually started out on a Honda motorcycle way back in 1983.
When you boil it all down, it comes back to this one simple, powerful concept. VTEC gave an engine two different sets of operating instructions, letting it be perfectly optimized for whatever you were asking it to do. It was simple, it was elegant, and it absolutely changed the game.
And that really makes you think, doesn't it? As we move into an electric future, we're leaving things like camshafts and valves behind. But that core challenge, it's still there. How do you get mind-blowing performance and incredible efficiency? What's going to be the next VTEC? What's the next brilliant idea that will give us the best of both worlds all over again?